Yes. I'll be using calculus today to calculate the rate at which the amount of mass that impacts the Earth from meteorites or comets from outer space. They use this in NASA to calculate a pattern of frequency over the years to see if there's any change in the amount of objects falling from space and impacting the Earth. Now, the first thing that I would have to find, I would use the mass in kilograms square I would use the mass of objects in grams that impact the Earth in kilometers square. Now, the first thing I would find, I would have to use that mass and I would multiply it by the area of the Earth. And I would, the part that I'm using calculus for is just to calculate the grams that impact the Earth per kilometer square. Now, the area of the Earth would be calculated by 4 pi times the radius of the Earth. And I would use the radius of the Earth as 6,378 kilometers. And I would use pi as 3.14, because it's a big mass. And this part here would be equal to 5.1 times 10 to the 8 kilometers squared. Now, to find this part here, there's a part where I'm going to use the calculus for. I obtain a frequency graph of objects that impact the Earth. Now, in this frequency graph, it looks like this. This side would be the measurement of the number of particle impacts, and this would be the mass of the objects. Now, at this point, the objects that impact Earth are mostly small objects, like meteorites or meteors. And as it comes down the graph, you get large objects like comets. But I obtained a frequency graph of objects that impacted the Earth in the year 2012. And the large objects like comet, which are over like the size of a car, did not impact the Earth in 2012. So this is outside of the frequency graph. So most of these other objects are objects like meteors from this point and meteorites from this point. Now, to calculate the mass of these objects, I would have to use calculus to calculate the area under this curve. The area under this curve of mass of objects that impact the surface of the Earth. They gave me a function. They didn't calculate the integral of the function, they just gave me a function and they said that they called it n of f and it was equals to 0.025 to the minus 0.9. And this is a function for the mass of the objects over this distribution. Now I wanted to calculate the mass of objects between a certain mass, between 1 to 10 to the 20 grams. Now this is 1 to 10 to 20 zeros grams, the large objects. Now to do this, I use a definite integral. And my definite integral was with these two from 1 to 10 to the 20, and I'm using the function that they gave me here, 0.025 to the minus 0.9, and I'm differentiating it with respect to m, because I want to find the mass. And when I work this out, I got 2.25 grams that were impacting the Earth on every kilometer square for that year. Now, to find the total mass of objects that were impacting the Earth in 2012, all I had to do was multiply this value by this. And I got that the total mass impact for the year 2012 was equals to 1,150 tons. Now, this is my way of showing that you can use calculus in this form of some use, so that I can find total amount that was impacting the Earth. This is just the surface area for